we are going to be testing different sugars and carbohydrates with Benedict's reagent. Benedict's reagent is a solution that is blue, and if it changes colors to anything else, then it's a positive test. The Benedict's reagent has been reduced. Does it take for a positive test? Well, all aldehydes will cause a positive test, and ketones will if there is an OH next to the carbonyl carbon. And so for both of those reasons together, all monosaccharides should test positive unless they're some kind of funny deoxy where it was missing this one. But anyway, so pretty much all typical monosaccharides would test positive with those two. However, when the sugars are in a ring, they may not qualify under those two. And in that case, when they're in the ring form, they need to have a hemiacetal group. And so that's what we're going to look at, is the presence of that hemiacetal on a disaccharide or a polysaccharide comes into play. Okay, let's look at a disaccharide. Disaccharide means it has 2 units of sugar, and so that's going to mean that there's 2 rings involved. Okay, on these structures, these are not chemical structures at all. This is getting kind of silly, and biochemists would actually call these cartoons. They are just representations of the structures. Really, there's an oxygen right there in these rings, and there are different OH groups and stuff coming off of that, but just as a general picture. I have used the little star to represent that this has a hemiacetal group on the right hand side. It's usually kind of on the upper right. And remember, that's the reactive part. Okay, so this is what usually happens. 2 disaccharides react, and what it is the hemiacetal group of one will react with an OH group on the other to form a link. And when they get linked, one of the hemiacetals is lost, but there's one left on the end. And this is how most disaccharides are. So this disaccharide would still test positive with Benedict's. Because it has a hemiacetal group. In the ring structure, they don't have the carbonyl, so they don't qualify as an aldehyde or ketone. So anyway, so that one's positive. And so we would say that this sugar is a reducing sugar. Positive with Benedict's means the sugar reduced Benedict's reagent. So this is a reducing sugar. Okay, that's the case with most disaccharides, but there's one kind of common exception. And if we'll look at this one here, let's say this is glucose and this is fructose. Now you notice that I have fructose flipped around backwards. The hemiacetal is on the left, or the reducing end is on the left, and that's not usually, we usually put that on the right. But the reason I did that is because with this particular disaccharide, this glucose hemiacetal reacts with the OH on this hemiacetal. So both hemiacetals are lost. And so this is a non-reducing sugar. Which means it will be negative with Benedict's, no color change. And by the way, sucrose is like this. Sucrose is a dimer, we would say, a disaccharide made from glucose and fructose. They react in such a way that they lose both hemiacetals, and you get a disaccharide that's not a reducing sugar. Sucrose. Sucrose, you guys might know as cane sugar or table sugar. It's the most common kind of sugar that we use at home. Okay, let's look at some other disaccharides. Well, here's sucrose showing a true structure. And I said that it doesn't have a hemiacetal. Is that true? Well, look on the right-hand ring. I will draw these for you in the standard format with the reducing end on the right. So I'll look at the right. There's the O in the ring. There's a carbon on either side, so it has the COC, but notice it does not have an OH that is right off of this carbon. This one does not count because there's a carbon in between. Okay, so this one does not have a hemiacetal like we said, so this is a non-reducing sugar. What about lactose? That's another disaccharide that's pretty common. Can you find its hemiacetal? Look on the right-hand ring, find the oxygen in the ring, find the carbon on either side, and there's an OH coming right off of that ring. So this one does have a hemiacetal. This is a reducing sugar. So if I test it with Benedict's reagent, I will get a color change.